Hello and welcome to this video about the Bayes theorem. In this video we will learn this important theorem which is related to the previous theorem we learned before about the total probability law. This idea of Bayes theorem and the Bayesian statistics are very used in science and scientific research. Here we will learn how to revise some previously calculated probabilities but working with new information. And these ideas were developed by Thomas Bayes in the 18th century, so it's not a recent idea. And we will use conditional probability, which is an idea, a concept we defined before. So the idea in this theorem is that we are able to compute the probability of belonging to one specific partition, could be B1, B2, B3, given that we know that A has happened. Remember this notation when we work with conditional probabilities, that where we use these ideas that we know that A is happening. So knowing that A is happening, we want to compute the probability, for instance, to belong to B1. So to solve this idea, to solve this term, we can use the probability of the intersection between them. So the probability in the numerator, if you take a look to the numerator of this expression, you can realize that here we are combining the joint probability of A and the partition By, any of the partitions, could be B1. So this is probability of A given B1 could be, or in this expression given By, per marginal probability of By. And what's in the denominator, it seems to be a very complicated expression, very long expression, but it's not. If you take a look to the denominator, you can be aware, you can realize that we are referring to the probability of A, marginal probability of A, but in the denominator, we are developing this probability of A according to the total probability law. So here you know that By represents each of the partitions, each of the incompatible, mutually exclusive events that were defined as a partition of the sample space. And there is other event which is A, and that's interesting for us and may have an impact on B, or vice versa. And in our example, when we define the total probability law, remember that we were talking about the probability to find someone who usually rides a bike on a daily basis, conditioned to being someone in the children population, B1, or from the adult population or elderly population. So before, we learned to compute P of A, as the area of this round the probability of A. But now, with the Bayes theorem, we will be able to compute the probability of B1, for instance, in this expression, probability of B1, knowing that the person we selected usually rides a bike on a daily basis. So, what we are doing here is to compute some kind of reverse probability. Once we know what is the probability of A, what's the probability of riding a bike, which is a number that it will go into the denominator. So using the Bayes theorem, we will be able to compute the probability of B1 given A. For the explanation, we will continue with the example we introduced before about different tablets from different brands, and these were B1, B2, B3. If you don't remember, please revise this video about the total probability law where it was explained. And there was an A event which was the probability of having purchased the tablet online, and we refer to this event as O. So we had several events such as A for Samsung, C for Sierra, PH for PH, what's the same notation, and we refer as O as the probability of having purchased the tablet online. So the question now is, if we choose a tablet, randomly selected of course, that was purchased online, what's the probability that the tablet is Samsung? So please notice, pay attention that we are studying the same probability but reverse. So here, this is the question that we need to answer. Remember the notation we defined. This is something that you need to define in all your problems. So here in this probability, we are computing this as 3 over 3 plus 3 plus 3. What does it mean? We are computing this probability as the number of devices that were Samsung and were purchased online, which were 3 devices over total number of devices that were present in the problem, plus over in the denominator the total number of devices that were purchased online. So these were 8. So there are 2 ways to solve this problem. The first way, it's quite easy to understand. It is 3 computers that accomplish both conditions, Samsung and purchase online, over total number of purchases online, not only this brand. And also there is another way to do it, which is computing the probability to find a device which is Samsung and online, and this is 3 over 30 because we have 30 devices in the problem, over the probability to obtain a device that was randomly selected and it was online purchase. So this is 8 over 30. And as you can imagine, the 30 disappeared from this expression, and of course we obtain the same result. So this is how it works. We apply the Bayes theorem to obtain some different expression of the conditional probability. I hope that you find useful this video. Remember to practice with the exercises and the exams that are available in poly format. Thank you for your attention.